All right, well, let's get started here today. Thanks very much to everyone who's joined me for Bell Performance's first webinar for 2017. I am Eric Bjornstad. I'm the Technical Information Director here at Bell Performance, and we are located in Central Florida. Last year I think we did 3 webinars that we offered on different topics, like I think we did one on how diesel fuel has changed over the years. We did another one on biofuels and the effects of their introduction to the national fuel supply, their effect on end users. Today we're going to talk about a topic, fuel tanks corrosion, storage tank corrosion, which is a nationwide problem, and we're going to talk about what to do about it. We are going to try and limit this maybe about an hour or so. We might run a little long, but we're going to try and keep things to time as much as possible. So for this first webinar 2017, we want to talk about a problem that affects anyone and everyone who either stores fuel or relies on stored fuel to get things done, and that is the problem of corrosion in diesel fuel storage tanks. Specifically, we wanted to talk about the report that was published in July of last year, 2016, by the EPA, summarizing their comprehensive research study on corrosion in underground storage tanks. And we're going to break this up into 4 main parts. First thing we're going to do is we're going to talk about some of the significant events from the last decade that happened, which brought us to the collective present, such that the EPA determined such a study was needed. Then we're going to look at, of course, at what they did, what they looked at, what they were trying to find, what their goals were. And then, of course, once you do that, then you have to look at the results. You have to see what did the EPA find, and then what recommendations did the EPA make that came out of what they found? What were some of the best practices that the EPA recommended the industry take up? And these are best practices that were informed by the results of what they found in their study. So to start off with, the research that the EPA did was it was a collaboration between the EPA and private industry. And the EPA was pretty clear that they had 3 main goals in all of this. First goal was they wanted to understand just how serious this potential problem might be. Second thing they wanted to do is they wanted to see if they could find or identify any predictive factors that might call them commonalities, if you will, between tanks that had corrosion problems and tanks that did not have corrosion problems. Were there any commonalities between them that might shed some light on the issue? And then the third, they wanted to develop a better understanding of the potential risks to both the environment and to human health that this corrosion problem might, potentially pose. Because when it comes down to it, the EPA's mandate from the federal government is to protect the environment, and human health is almost always inextricably linked with environmental health. So to get some perspective on this, we have to consider just how many tanks there are out there. There are at least 100,000 federally regulated underground storage tanks just storing diesel fuel. So it doesn't count gasoline, doesn't count any other kind of fuel, just diesel fuel. And it also doesn't include above ground storage tanks, and it doesn't include all those small unregulated tanks on farms and residential tanks that are holding home heating oil. So there's an awful lot of stored fuel out there and an awful lot of fuel storage tanks. And many of these tanks are quite old. And the older the tank, the greater likelihood there is of a problem with it developing. And if a problem does develop with that tank, you have some potentially really serious consequences that could arise. So to get a better understanding of the problem and why the EPA felt that it was important to do what they did, we first, it helps us if we understand the history of the issue. And in order to do that, we go back to 2007. Fuel has been stored for a long time, but 2007 is really when the first significant things started happening. 2007, you get the first known reports of this thing called vapor space corrosion, and it's being reported on by the Petroleum Equipment Institute on their website. So you have vapor space corrosion, where internal metal components in those tanks above the fuel line are, experiencing significant corrosion damage. And so these are areas above the fuel line, which means they're not in regions submerged in the fuel. And that is a key distinction, because prior to 2007, storage tank corrosion was considered a minor problem. And when it did occur, it was really only occurred in the lower, what they call the wetted portion of the tank. So now, 2007, there is a new and troubling trend that the industry is starting to see. And 2007 is also significant for another reason. It is about the time that ultra-low sulfur diesel becomes the predominant fuel in the diesel fuel landscape across the country. And you probably know that taking out sulfur from ultra-low sulfur diesel makes those makes the ULSD a lot less able to resist microbes. But what they also, not only did they dictate that they had to slash the sulfur content, but they also had to change the fuel's composition in terms of the levels of aromatics, the olefinic content, and the saturate content. And when they did so, when they reduced the amount of aromatics and olefinics, those tend to be microbial inhibitors. So you take those out, you have less components in the fuel that resist microbes. So that's problem number one. If you concurrently increase the proportion of saturates, well, saturates happen to be something that microbes love to feed on and love to metabolize. So now you're increasing those at the same time. So it wasn't just the removal of the sulfur, it was the change in the composition of the fuel around 2007, creating an ultra-low sulfur diesel fuel, which is a lot less resistant to microbes. And thus, you have, the potential for serious microbial issues, which a lot of people think is what was contributing to this vapor space corrosion problem. Another trend that was happening is that, these tank owners were reporting these instances of vapor space corrosion, but they had not changed any of their maintenance practices. They were still doing the same things that they had always done when they did not have any problems. So it's not like they were just ignoring their tanks. They were still paying attention to them, but now they are having these problems. And so you have this new phenomenon that the industry is starting to see. So we jumped to 2010. 2010, the Petroleum Equipment Institute that we mentioned before, they do a survey. They do a 5-question survey for tank owners and operators to try and get a better handle on what they were seeing with respect to corrosion and damage in their storage tanks. And the results of what they found suggested pretty strongly that if you had any metal components in your storage tank, whether they were in contact with fuel or whether they were above the fuel line and just exposed to the vapors, any metal components in those tanks could potentially be affected by corrosion. So now momentum is starting to gather in the industry. 2010, you're talking about 4 years, 3-4 years since the problem first started getting noticed, and the industry starts to realize that this problem is not slowing down, it's actually accelerating, it's actually getting worse. And so more and more people are starting to look up and say, hey, maybe we ought to think about doing something about that. So we jumped 2 years later to 2012, and the Clean Diesel Fuel Alliance does what was really the first rigorous study of underground storage tanks that really had ever been done. Now, they studied 6 operating systems, 6 operating USTs, so to speak. And after they broke everything down and they looked at as many different factors and as many different angles as they could think of, they came to a few conclusions. They concluded that a lot of this corrosion, this metal corrosion in storage tanks, was being caused by low molecular weight acids, Low molecular weight acids are basically lightweight acids like acetic acid, which is vinegar, like formic acid, ones like that. And they were speculating that was being caused by these light acids that they found in these systems, and that these light acids, they didn't just magically appear. They were in there because they had been produced as the metabolic byproducts of microbes in those tanks. So when you start suggesting that, hey, microbes, we've got some strong evidence that microbes are really what's causing this issue, well, then the question then follows from that of what's contributing or what's enabling those microbes to thrive. Why are they now causing problems? Well, CDFA found a few more things that might shed some light on this. And it's really the fact that they found widespread contamination by a number of different things in the diesel fuel and the water samples that they took from those tanks. They found ethanol. Presence of ethanol in many of the fuel samples they took and the water bottoms. Now, keep in mind, this is diesel fuel. Why is there ethanol in the diesel fuel? Well, they say, well, maybe there's some kind of what they called switch loading contamination going on. You got the same companies distributing both diesel fuel and ethanol. And so maybe you got a truck that transports ethanol gasoline, and maybe they don't clean it out completely, and you get a little bit of ethanol left in there. And so the next thing they do is they deliver a load of diesel. Well, now that diesel has trace contamination of ethanol, and certain kinds of microbes like acetobacters love to feed off of ethanol. So they metabolize the ethanol when it's in the storage tank, and they produce acetic acid and other lightweight acids. And those then volatilize, turn into vapor, and go up in the vapor space. And essentially, you have acidic vapor in the air in those tanks, causing corrosion over a long period of time. They also found trace amounts of glycerol. Now, glycerol, if you know anything about biodiesel, glycerol is it's a waste product that comes out of the biodiesel production process. Yeah, it's not really supposed to be in there. So if you're finding glycerol content, well, that's telling you that maybe they're not being as rigorous in their processes as they could be. But for the purposes of the question of why, if there's glycerol in there, glycerol is another thing that microbes like to feed off of, and they metabolize it and produce other kinds of acids like lactic acid and like glyceric acid and this stuff called propionic acid. All of those are perfectly capable of doing exactly the same thing as acetic acid, volatilizing, forming vapor, going up into the vapor space, and causing corrosion. So based on the results of the CDFA study, which is now being, making its way through the industry, the EPA takes notice, and the EPA decides that it needs to take the lead in doing some really rigorous, in-depth research. They need to put their muscle behind it, so to speak. And so that brings us to where we're at today, where we're going to talk about what the EPA found. It's a problem that warrants some serious research. But before we talk about what the EPA found, let's talk about the consequences for the people that this problem affects, which are tank owners and tank operators. What are the potential consequences, potential problems of storage tank corrosion for these people? Well, if you start thinking about it, potentially some of those problems could be pretty serious. The consequences could be pretty painful for those people. Even if you just start with the most minor one, their filters start plugging faster. They start getting this corrosion debris, this coffee ground looking debris. And so they have to change their dispenser filters more often, which, that's extra. You have to buy more filters. So that's an extra expense. They have to have somebody pay attention and do it. That's an extra expense. But by and large, not really all that much of a hassle. But when you start talking about corrosion in the vapor space, can damage things like release detection equipment and the release prevention mechanisms that all of these tanks have. Now you start talking about a really potentially serious thing. And that's really what the EPA is paying attention to. They, you know, those pieces of equipment are installed in tanks to prevent fuel from being released into the environment. But if the corrosive damage is serious enough, if the tank bungs and the gaskets and the release prevention equipment and even the walls and bottoms of the tanks themselves, if the corrosion is serious enough and any of those things get damaged or breached, now you have a release of fuel into the environment. And that's when it gets really serious, because first of all, it's a health hazard. It's a hazard to the health of the community. And it places that tank owner at tremendous liability. They have to pay for cleanup for everything associated with that. They are liable. And so tank owners and tank operators pay close attention to what the EPA found and what the EPA recommends that they do, because of the potentially serious consequences if they don't. So let's look at how the EPA studied this matter. They did their studies in the first part of 2015. They had chosen 42 underground storage tanks that were located across the country. 5,000 to 20,000 gallon capacity. You know, we won't say half and half, but a good distribution of both fiberglass tanks and metal tanks. And in terms of geographics, as you can see, they were clustered in, pretty much across the country: San Francisco area, Colorado, the Midwest of Missouri, southeast of Louisiana and Tennessee. You've got the upper Midwest in Illinois and Indiana, and you have 3 of them in New England. And so a couple of characteristics of the test pool that the EPA noted, they said it's not completely representative of the entire state of the country, because there wasn't a random sample and it didn't include emergency generator tanks. And say, okay, but up to this point, it is by far the most comprehensive study that anybody has ever undertaken up to this point. I mean, up to this point, the CDFA study in 2012 was the most comprehensive, and that had 6 tanks. This has 42. Now, in terms of how the EPA studied this, well, they took some of the test protocols that were being developed by the Coordinating Research Council, and they piggybacked off of those. They contracted with companies like Battelle, like Technology, they're in the picture, to do some of this work. And they used a lot of in-tank cameras. They took a lot of photographs to visually inspect and see what the inside of those tanks looked like, to see if they could see where the corrosion was and how serious it was. They collected a lot of samples as well, fuel samples, water bottom samples, and vapor samples from the vapor space. And they then shipped those off to third-party laboratories to have complete analyses done to see what the characteristics of those samples were and if they contained anything unusual. And then, of course, they followed up behind this with as detailed questionnaires as they could for every single tank as far as its history. What was its storage history? What were the maintenance practices? All of that kind of stuff, to see if they could find anything meaningful, any meaningful trends and commonalities that could come out of those situations. And they did. They found, basically, when they're writing up their results, they found 7 key takeaways that they decided were worthwhile enough to communicate to the general public. So what are they? First takeaway, corrosion in storage tanks was a lot more common than even the EPA would have predicted. They found 83%, that's 35 out of 42 storage tanks, had either moderate corrosion or severe corrosion. Now, they defined it a little more in depth in the 62-page write-up that they did. For the meantime, we'll just use the terms of moderate corrosion and serious corrosion. So 83% of those tanks had corrosion damage, and the corrosion damage, when they were looking around and they were seeing where it was located everywhere. All types of metal components in those systems had corrosion damage. If you own a tank, you know what the different parts of that tank are. So, you've got bungs, and you've got flapper valves and risers, ball floats, all sorts of things. That one that you see, the STP shaft here, that part, which it exists in both the vapor space and then down in the wetted part of the fuel. This was the single component that had the most tank corrosion across all the tanks. This was the part that was most affected that they found. So a lot more corrosions going on than even they would have predicted. The second interesting thing is that most of the tank owners of those tanks didn't know that corrosion was happening in their tanks. And this is a takeaway because before they looked in the tanks, they asked all of the owners as part of those detailed questionnaires about, have you had corrosion problems? Are you seeing any symptoms? Things like that. And less than a quarter of the tank owners reported symptoms of or signs of corrosion or reported existing or previous corrosion problems in those tanks. Suddenly, you've got 80% of the tanks actually have corrosion. So there are a whole lot of tank owners who found out really for the first time that, contrary to what they were observing, they might have some serious corrosion problems going on in the present time in the tanks that they owned. The third finding they found was that corrosion affected both metal and fiberglass tanks equally. Now, the reason why it affected fiberglass tanks equally was because of the metal components used in the fiberglass tanks. So pretty simple explanation there. Takeaway number 4, when they looked in the vapor space, the higher up they went in the tank, the more damage they saw. Now this picture here is one of those STP shafts. You can see the very characteristic tubercle, I think is how they put it, tubercle looking corrosive damage on this STP shaft. But basically, the higher you go up into the vapor space, the more damage they observed. Takeaway number 5 had to do with the things that they found when they started analyzing those samples. They found widespread contamination in the diesel fuel samples and in the water bottoms by things that you would not necessarily expect to be there. Remember the CDFA study found ethanol content in all of their samples. Well, the EPA found the same thing. They found ethanol being present in a lot of the samples, which, alludes to the old switch loading contamination hypothesis. They also found gasoline contamination in diesel fuel, not something you would expect. Another couple other things they found: biodiesel content and glycerol content. Now, biodiesel content is not a shocker. They should find biodiesel in there because most on-road diesel fuel has biodiesel in it. They shouldn't be finding glycerol content because, again, glycerol is a waste byproduct of the biodiesel manufacturing process, and glycerol is something that microbes like to feed off of. Now, so glycerol shouldn't be in there, but why is it important to mention that they found biodiesel in there? Well, biodiesel is susceptible to the effects of water. And as we're going to see, water is present in most tanks. And the reason why this matters is because when water, whether it's free water or whether it's dissolved water, when it comes into contact with biodiesel in these biodiesel blends, in this diesel fuel, it will interact with the biodiesel molecules, with the methyl ester molecules, and it will hydrate them. And that leads to hydrolysis chemical reactions, which break those biodiesel molecules apart, and they start to form things that you don't want in there, like chemical salts and soaps and peroxides. And those are things that microbes like to feed off of. So not only are they finding glycerol that microbes like to eat, but the simple fact that there's biodiesel in there means that any water that makes its way in there is going to break that down into other things that microbes like to eat as well. Takeaways number 6 and 7 concerned what they found when they tested the characteristics of the fuel samples. The interesting thing they found is when they tested the fuel samples according to the specifications, the ASTM specifications for diesel fuel, they found that virtually all of them failed the ASTM spec in one area or the other. The most common area that they failed was in water and particulate content. And that matters because the seventh takeaway they found was that failing water particulate and water content tests were what had the highest correlation to having severe corrosion in storage tanks. So let's restate that to make sure that we're clear. If you went out to your storage tank and took a sample of diesel fuel and then you shipped it off to be tested and it came back and said, yeah, it passed this, and this, but oh yeah, for the water and sediment test, it fails. It's got excessive water content and it's got excessive sediment content. What that would tell you, apart from the bad news that your fuel is not in spec, but it would tell you that there is a high correlation to the possibility that your storage tank that you have has severe corrosion problems going on in it right now. So those were the 7 key takeaways that the EPA had coming out of the results of their study. Now, they talk a lot about microbially induced corrosion. Sometimes you'll see it abbreviated as MIC, capital M-I-C. Now, the EPA, when they're starting to comment on what all of these things mean, some of the things that they said was, you know, we set out to try and prove or see how well we could prove what was causing microbially induced corrosion. And they said, well, we didn't exactly get to the point where we could say we have a definitive rock solid proof. But the hedging people that they are, the EPA said there is a lot of evidence that microbes are doing some really bad things in these tanks. We need to do some more study on it. Now, a couple of other things that they found was they said that they thought that the results of what they found, the fact that they found a lot of things in like the water samples, you know, they found low acidic pH levels, they found ethanol contamination, they found acid and glycerol content. They said all of those things are associated with microbial growth, and they found those in a lot of the water samples. So they said that, along with some other things, constituted strong evidence of a link between biofuels in the diesel fuel and microbial corrosion problems. Now, why do they think that microbes are linked to corrosion? And, you know, apart from the circumstantial relationship, is there anything more than that? Well, if you want to understand how microbial induced corrosion happens, there's a few easy things that you can cite. First of all, microbes, it's well known that microbes, they will metabolize and feed off of things in the storage tank, and they will produce weak acids, the weak, low molecular weight, lightweight acids that we were talking about earlier. Now, those acids actually do two things. As we mentioned before, one of the things that they do is that because they're lightweight, they turn into vapor. They volatilize, and then they go up into the air and they start corroding all of those metal components above the fuel line. But another thing that they do is they act as a food source that other kinds of bacteria and microbes in the storage tank will feed off of. And when they feed off of them, those will essentially turn them from, you know, weak organic acids into strong inorganic acids. And when you're talking about strong inorganic acids, you're talking about acids like sulfuric acid and nitric acid. And those, as you may surmise, are really, really corrosive to storage tanks. Another thing that microbes will do, some of the anaerobic kinds of microbes, like the sulfate-reducing bacteria, the SRBs as they call them, those will metabolize sulfate molecules in the storage tank, and they will produce hydrogen sulfide gas. Now, that's H2S. Now, apart from the fact that H2S, if you were to breathe it in, would kill you really quickly. It is extremely corrosive to storage tanks when it is dissolved down below the wetted part of the wetted portion of the tank. So sulfate-reducing bacteria produce corrosive H2S gas. Another thing that different kinds of microbes will do, and these are primarily anaerobic bacteria, is that they'll produce high concentrations of carbon dioxide as a result of their metabolism. And that carbon dioxide will dissolve in the tank water, in the water phase. And when it does that, it will turn into carbonic acid, which is another highly corrosive agent that they find in these tanks. And then, lastly, you have this thing called galvanic corrosion. Galvanic corrosion was on the last point that we talked about down here. Galvanic corrosion is one of the dominant ongoing mechanisms that explains how tank surfaces under the fuel line, the wetted portion, how those become corroded. And basically, without going too much into the physics and the chemistry of it, basically what happens is that microbes will end up producing stuff like iron sulfide. They'll produce biofilms, and they'll collect on the surfaces under the fuel line. And essentially, they create what they call a galvanic couple. What that means is essentially produces the conditions that are necessary to have an electric current form. And so the electric current, which is movement of electrons, the electric current will basically move across those tank surfaces and act kind of like an electrolysis reaction, and they will produce corrosion on those tanks. Typically, it looks like pinhole corrosion is how they put it. But that is one of the predominant ongoing mechanisms that happens in these storage tanks that explains how corrosion happens. So the EPA may not have found the smoking gun in this study, but they ended up being a lot closer to that point than when they started. So in that respect, the study was a success. Now we can turn our attention to the best practice recommendations that the EPA stated. This is the meat of the matter for us. This is the most important thing, because you know why this stuff is happening, you know how it's happening, but now you want to know what you can do about it. What's the best practice recommendation for what you can do about it? So let's talk about it. Recommendation number one, the EPA said owners and operators of storage tanks need to conduct visual inspections of their filters and of the inside of their underground storage tanks. And they need to do this on a regular basis, and importantly, even if they haven't seen any symptoms. And it doesn't matter if the tank's fiberglass or steel, they need to do this. That's action item number one. Again, the reason why, as we said before, it was established that you can have severe corrosion problems in that tank, and it can be going on even before any symptoms really show up. Again, remember, less than 25% of those tank owners thought they had a problem, but yet 80% of them did. Think about it like blood pressure. Okay, it's kind of like it is kind of like checking your blood pressure. You know, if you have high blood pressure, most of the time you feel fine. You do not think anything's going on, but you will feel fine until something happens, right? And when something does happen, then it's really, really serious. So that's why your doctor will tell you, check your blood pressure even if you feel fine. Same kind of concept. You don't have to have any symptoms for something serious to be going on. So action item number two was tank owners need to regularly monitor for water content and then try to remove any water present that they find. Now, if you've been in the business for any amount of time, you probably already think you know this, and you may well know this, but you would still be surprised at the number of owners and operators of fuel storage tanks across the country who do not actually do this. I mean, up to this point, it should be pretty clear that if you have a water phase in your storage tank, that is going to contribute to a corrosion problem. And not just in how it contributes to microbial growth, but it also does it in something as simple as the oxygen content of the water. Now, remember we talked about galvanic corrosion, and we said that was the predominant mechanism for corrosion. Well, this is another predominant corrosion process that happens. See, oxygen can dissolve in both water and in fuel. But oxygen is actually more soluble in fuel than it is in water. Under ideal conditions and in the absence of anything that, any mitigating factor that increases it, just naturally occurring fuel and naturally occurring water, you can get 60 parts per million of oxygen content in fuel, but only 8 parts per million oxygen content in water. Now, if you have a water layer next to a fuel layer, what's going to happen? Well, law of osmosis, or whatever they called it in science class, dictates that something in high concentration will move to an area of low concentration. It will migrate. And so what happens in tanks is that the oxygen will diffuse, or it will move from the fuel, high concentration, into the water, low concentration, to try and equalize out the water content, the oxygen content. If this happens along tank surfaces, you will get localized pockets of oxygen, and that will speed up localized corrosion and metal loss where that oxygen is. And this can be sped up, made to go even faster if the temperature is warmer, if there's CO2 there, if there's presence of hydrogen sulfide, if there's the presence of any number of other kinds of things like acids and salts. That can all make that process go faster. So water in the tank does a lot of really bad things. Now, some people might say, well, water's fine. It's fine for those guys, but I don't have a water problem because my fuel, I have a high turn system. My fuel gets used up too fast. And the answer to that is, well, not necessarily. Yeah, if you don't let your fuel sit there for any amount of time and you move it out, water may not necessarily all collect in your tank, but it is going to collect in their tank and cause them problems. See, when in the fuel distribution process, the refinery is really where it starts. And when the fuel leaves the refinery, it is at its highest temperature. It's warm when it leaves the refinery. And then as it travels along the distribution system, whether it goes to a pipeline, or whether it goes to barges or tanker trucks or whatever, it is cooling down all along the way. As it cools down, the water that was present at the beginning can start to drop out. It's really just a matter if it drops out in your tank or if it drops out in the tank down the road. But if it drops out in the tank of the person who's distributing the fuel to you, then you do have a water problem, no matter if you've got a high turn system or not. And there are any number of ways that water can get into the system. If any of the things like the fill boxes are damaged, the fill cap gaskets are damaged, if you got any loose fittings, loose plugs, if you get rainwater in your tank sumps, if you get rainwater in your spill buckets, spill buckets can hold 5, 15, 20 gallons of water. And when somebody opens that up to put, let's say to put fuel in that tank, all that water is going to go right into your tank. And then, of course, just natural condensation. So the bottom line here is that despite your best efforts, you are more than likely going to have water present in your tank at any particular time. So the EPA says, hey, keep an eye on it, monitor it, and when it gets to a certain point, remove it as much as possible. Some people say, well, I don't really have to monitor it because I have ATGs, I have tank gauging systems. And those work great, except for the fact that you should never rely on those alone. You should always have a human backup. You should always verify your results by doing a manual check of your tank at the same time, because how do you know that your ATG system is functioning properly? How do you know that if you didn't know you had a corrosion problem, how do you know that your ATG apparatus hasn't been damaged by corrosion? You don't. unless you verify the results manually at the same time. Now, how much water should be of concern? It really doesn't take much water at all for a microbial problem to manifest itself. Less than a quarter inch is more than enough. But when you start getting above that, the general rule of thumb that groups like the Steel Tank Initiative or Steel Tank Institute, say is that if you get an inch of water in your tank, you're at the point where you got to get that out. If you let it go even longer and you get 2 inches of water, you need to shut that tank down. Don't let anybody get fuel out of that. Get that water out. So those are just some reference depths to give you some context here. So action item number 3. You should filter the fuel for water content and particulate before it gets delivered into the tank. Now people say that's crazy talk. I can't do that. Well, that's what the EPA is recommending. But then the EPA says, well, some people say they can't do that. The next best thing is get your fuel drop and then circulate it so that the fuel's combined with what was in the tank to start with, and then filter that combined fuel for water and sediment. Now, why is this necessary? Well, remember that excess water content and particulate content was the strongest correlating factor with corrosion in that storage tank. Now you might say, well, yeah, okay, that's true. I'll give you that, but we take really good care of our fuel. We don't need to filter it. Well, even if you keep your fuel in peak condition, that does not mean that everybody else around you cares as much as you do, and doesn't mean that they are as careful as you are. And when you get a fuel drop, you are relying on the fuel supplier to deliver you product that is in as good condition as yours is. If they don't, they're going to be delivering you particulate, sediment, sludge, water content very likely, and maybe even microbial precursors. And that all of those are going to go into your clean fuel and your clean tank. So if you heed the EPA's best practices here and filter after you get that, if not before, your fuel is going to stay as clean as you want it to be. Another interesting fact is that it really doesn't take, over time, it doesn't take that much particulate content to really build up in your system. I mean, if you take fuel that's only got, let's say 10 milligrams per liter, that's not very much. 10 milligrams per liter particulate content. Let's say you got a 10,000 gallon tank and you get 1 fuel drop per week. So you use 8,000 gallons of fuel per week, which again, for B2B people, isn't all that much. If you go a year, you'll have 35 pounds of solids in your storage tank. And then if you're a higher volume one, like a terminal, you got these really big tanks at the terminals. And let's say that at a fuel terminal, they go through 60,000 barrels a week, 2.4 million gallons. 10 milligrams per liter particulate content. That tank, after 1 year, will end up having 11,000 pounds of external particulate solids in that tank. So a little over time, multiplied over time, can end up being a lot, basically. Action item number 4. Tank owners should contact UST service companies to further evaluate the extent of corrosion in their system. If they find corrosion, or even if they just suspect that it's there, they should not hesitate to partner with service companies. Now, the EPA recommends this because they know that few tank owners, if any, have the technical knowledge or the resources to fix their own tanks, or even to more fully evaluate the extent of corrosion problems and corrosion damage in their tanks if they start to see signs that there might be an issue going on. Now, a service company, a UST service company, they are the experts in their field. Solving corrosion problems, replacing and repairing things, that's in their wheelhouse. What the EPA does not want to have happen is for a tank owner to suspect they have a corrosion problem, suspect that something might be going on, but because they're intimidated by the daunting prospect of having to do it themselves, so to speak, they put it off. They feel they don't have the resources, they don't have the knowledge to solve the problem, so they just ignore it. The EPA does not want you to do that. They say partner with somebody whose job it is to fix stuff like that. And then piggybacking off of that is, of course, if you do find that something's damaged like that, you got to repair it. You got to replace it as quickly as possible. How quickly is as quickly as possible? Another way to put it is how quickly can corrosive damage from, let's say, from MIC, how quickly can that happen? Well, the literature values for corrosion in diesel tanks is 0.3 to 0.5 millimeters per year. Now, by literature values, what we mean is that you don't have micro problems, you have clean fuel, you don't have the presence of any accelerating factors. It's, it's just, things are pretty good in that tank. You can still get up to 0.5 millimeter per year of corrosion. But what matters is when you start adding other factors in. You start getting localized oxygen pockets. You start getting sulfate-reducing bacteria producing hydrogen sulfide. You start getting things happening in that tank that accelerate that rate of corrosion by up to 70 times. And if that happens, then you go from 0.5 millimeter per year to 35 millimeters per year. And those are the kind of situations you hear about that sound crazy. Like the one where they had an 1/8-inch 304 stainless steel plate in the tank, and it was perforated by microbial corrosion in less than 1 month. It's, that's unusual, but it does happen. So those are some guidelines as to how quickly corrosion can happen in your tank. And then the 6th recommendation was, so far, the EPA's recommendations have covered, categorically speaking, tank conditions and fuel condition of both stored and incoming fuel. They've covered housekeeping measures to deal with contaminants and the need for the tank owner to not put off essential repairs. This 6th and final recommendation from the EPA addresses preventive measures that can be easily done by tank owners and operators themselves. And that is the use of both biocides to kill existing microbes in the tank and these things called liquid corrosion inhibitors to help protect the tank surfaces from corrosion damage. So what is it about these that made the EPA specifically call these 2 kinds of treatments out? Why did they do that? Well, because the EPA knows that biocides and corrosion inhibitors directly address the problems that tank corrosion is associated with. So let's talk about biocides. Given the link between storage tank corrosion and microbial activity, it stands to reason that the EPA would recommend that tank owners incorporate something into their housekeeping that most directly targets microbial growth. And biocides, as a class, are the only chemical treatment that kill active microbes. So if you use them, you can use them in both a remedial manner and in a preventative manner. So if you have a tank and it has microbial-induced corrosion signs in it, then very likely it also has microbes in it. It has an existing microbial presence. If you treat it with a biocide, that's the first essential step to killing those microbes, and it is the only way to stop microbially induced corrosion from progressing. That makes biocide treatment a remedial benefit. On the preventive side, they recommend that you don't just treat one time, but you treat with low levels of biocide on a regular basis, on, let's say, a quarterly basis. If you have a low level of biocide consistently present in the fuel, that prevents microbes from getting established in that tank, and thus it becomes a preventive way of treating that tank as well. And this is a radical departure from the traditional rule of thumb that the industry had really held for years. I mean, the school of thought was if you kept the water under control, if you stayed on top of water problems, you would not have microbe problems. But they started seeing around 2007 with all those people that were controlling water. They were doing the same things they always did. yet they were having corrosion problems. So as they saw in 2007, what used to work does not work anymore. And it is now clear that water control in your storage tank is not enough to prevent microbe problems. You have to take extra measures, and that means regular use of biocides as the EPA recommends here. Now, there's a lot to be said about how to select the biocides. Biocides are mainly delineated by type of chemistry. They're not all the same, and different chemistries, whether you've got isothiazolone, boronate, thiocyanate, you've got some other ones like dibam and nibam, or some of these work better than others in certain situations. At the risk of overgeneralizing, there are 4 main types of characteristics that you would want to look for if you were trying to select the best biocide to use. First thing would be, how fast does it kill? What's the kill speed? That should be in hours, not days, of course. Second one is kill length. We typically consider this to be the most important one. It's the amount of time that a biocide will maintain 100% kill rate in the fuel. Now, how long should you look for? We're not talking about months here, we're talking about weeks. 4 weeks is about the best that you're going to get within the industry. And that means that there are plenty of biocide chemistries that are less effective that only maintain a kill rate for 1 to 2 weeks. And that is no good compared to 4 weeks. So kill speed, kill length, effectiveness in both fuel and water. Typically, you will add a biocide to the fuel portion, and it will kill microbes, that it comes in contact with, but it will migrate to the interface between the water and the fuel, and then it will cross that interface. As it crosses that interface, it's now, of course, entering into the water phase. But it has to move across the interface, which means it has to move across all of those microbes in that biofilm that's at that interface, and so it's going to, hopefully, it's going to kill all of those. And then, hopefully, if it is a biocide that it has maintained effectiveness in both fuel and water, then it will migrate into the water and continue to kill all the chronic microbes that are in that water. There are a number of biocides that cannot do this. They reach water and they become deactivated. And that is not an optimal situation. Fourth one, impervious to pH changes. There are some biocide chemistries that are less effective in acidic environments. And this is a problem for obvious reasons. Acidic conditions means microbes. Microbes make low, weak organic acids that turn into strong organic acids and turn the environment acidic. So having a biocide that's designed to kill microbes and yet doesn't work well in the environments where microbes thrive doesn't seem to make a whole lot of sense. So those 4 things, if you pay attention to those 4 things, you're going to be one step ahead in the game. And it is important to make a good choice, because if you're going to spend money on something like this, you have expectations that it's going to solve your problem. So you want to make sure that you select the right one. And if you are trying to decide, if you know that this is something that you need to do, but yet you don't really know what is the difference between all these trade names you hear. You've heard of BioBor, you might have heard of Kathon, you might have heard of Biocides, which is the one that we make. There are some other ones out there, AquaTreat. What's the difference between them? Well, there are differences between them. And we have some really good information on the Bell website that actually spells out the differences here. So if that's something that you think you need to learn more about, definitely consider stopping by the Bell website and accessing that information. There's a lot of good stuff, a lot of useful stuff on there. All right, so that's biocides. But what about the other thing that they recommended? Liquid corrosion inhibitors. A liquid corrosion inhibitor is simply a chemical. You put it into the fuel, and then as that fuel touches tank surfaces in the tank, it will actually migrate and form a protective layer on all of the tank surfaces that fuel touches. And that protective layer protects those surfaces from corrosive damage. Corrosion inhibitors are usually added at pretty low treat rates. 1 to 10,000 is typically 1 to 10,000, between 1 to 10,000 and 1 to 20,000 is the sweet spot. And the EPA specifically recommended a type of corrosion inhibitor that uses a chemistry called filming amine. And the simple way to explain it is what I just said a minute ago. The chemistry will migrate to the surfaces, the tank surfaces that treated fuel touches, and it will form a layer of protection on that surface. Now, there are some different options for corrosion inhibitors, and so it is important to point out that there are some reputable corrosion inhibitors out there that actually provide additional benefits other than just corrosion inhibitors. In fact, that's one of the things that we really sought out when we formulated our corrosion inhibitor, which is called tank treatment SDF. And when we talk about additional functionality, we're talking about sludge dispersants and we're talking about biomass dispersants. What this means is that in addition to protecting the tank surfaces from corrosion like the EPA recommends, this kind of chemical will also, when it comes into contact with petroleum sludge in the tank and the fuel system, it will actually disperse it and we say solubilize, but actually dissolve it back up into the fuel. And so over time, if you have treated fuel in that tank for a period of time, it will actually clean the tank of sludge, clean out the fuel system over that period of time, which is always a good thing. We said biomass dispersant, and this is an interesting one because if you know anything about microbes, you know that there are some microbes, typically aerobic microbes, that over the course of their life cycles, they produce these polysaccharide slimes that will aggregate together and they form these things that we call biomass formations. Now, biomass sticks to the walls of the tank, and then you will have microbes that grow in the biomass and grow behind it. Now, the problem here is that if you put a biocide into a tank whose walls are covered with sticky biomass, that biocide's not going to be able to get to all those microbes. So they will essentially be protected from the biocide that you want to put in there. But if you first add, or if you add alongside the biocide, some of this biomass dispersion formula, the biomass dispersant will actually attack the biomass and will start punching holes and breaking it apart. It will disperse it, essentially. And that enables the biocide to then work its way in behind it, target all of those microbes, get exposed to them, and kill all of them. So the bottom line, if you use something like tank treatment SDF alongside that biocide that the EPA recommended you use, not only are you going to be protecting your tank surfaces from corrosion, but you're also going to make the biocide actually work better because it is a complementary formulation with complementary functionality. Now, when you're talking about both biocides and corrosion inhibitors, but really for almost any other chemical fuel treatment that you put into the fuel, they do not work optimally if they are not applied properly. Now, that's not to say that things like this are really complicated to apply, but it does take more than just dumping a bottle in at the top of a fuel tank and leaving it there. Chemical treatments like biocides, like corrosion inhibitors, like sludge dispersants, water absorbers, these kind of chemical treatments, they only work if they can come in physical contact with their targets, physical contact with the microbes or the sludge or whatever. So the best way to apply them is the way that gets them mixed in as best they can into the fuel and then brings them into maximum proximity with whatever they're trying to target. How do you do this? Well, the best practice would be if you did some kind of direct injection into the fuel line of that tank. But that it probably is not feasible for all but the largest customers, like let's say power plants. So typically what they will recommend is that you add something like a biocide or a corrosion inhibitor. You add it to the fuel, and then you circulate that fuel for a given amount of time. Depending on the tank size, it could be 12 hours, it could be 4 hours. If it's a really big tank, it could be 24 hours. But as you circulate it, it gets more and more mixed into the fuel, and you get the best possible dispersion. You get the best possible what they call residency time of that fuel treatment in that fuel. And so it's going to work the best for you if you're able to do that. Now, this is where some entities start shying away from doing what's best for their stored fuel, because when you start telling a busy company who's already stretched to the limit, you start telling them that, hey, you got to use these two things. Oh yeah, and by the way, you've got to employ somebody to make a special effort to make sure that they're mixed in properly, or else they're not going to work as well as you want. They start hearing that, they start feeling like they don't have the time, they don't have the manpower, they might not even have the willingness to, to add something additional to their plate. I mean, they know they need to do it, but, sometimes you got to make choices, right? This is where you start considering where hooking up with a service partner might be in the best interest of that company. A good service partner can take all of this stuff off the plate of a busy company. A good service partner essentially will handle the fuel maintenance, the fuel service, and they'll do what they call fuel PM, fuel preventive maintenance. They should also, the better ones, should also be able to do tank cleaning. They should be able to do fuel filtration or mechanical fuel processing. And very importantly, they should be able to back all of it up with diagnostic testing of the fuel that shows that the condition of the fuel has changed, basically. Now, this kind of service partner we're describing here is different than the kind of service partner the EPA was referring to. The EPA was referring to a tank repair company, and they're still telling you that you want to consider partnering with those people. But we're talking about something just a little bit different. We're also not talking about fuel polishers specifically. See, tank service companies, the kind that the EPA was talking about earlier, they are good at repairing tanks, replacing tank parts. That's their wheelhouse. But they don't really get involved in the service of the fuel, the service of the fuel itself. Fuel polishers, you can find, if you really want a fuel polisher, it is really easy to find a fuel polisher. Fuel polishers are not difficult to find, and they will mechanically clean the fuel. But most fuel polishers typically are not strong on the chemical side. They're not really strong at using the best chemicals, and that's one of the reasons that that's one of the reasons we're here in the first place, is the fact that takeaway number 6, the EPA said use biocides, use liquid corrosion inhibitor chemicals. So a good service partner is going to be a little bit different than a tank service company. It's going to be different than a fuel polisher. A good service partner essentially should be able to provide you a turnkey service, basically. That means they can handle all of the important elements, the chemical treatment of the fuel, the mechanical fuel processing and the tank cleaning, and the diagnostic testing. They can handle all of that, take it off your plate. But if you don't need all of that, they also should be able to break out only what you need. So given that Bell Performance itself has been doing business with stored fuel entities in Florida really for decades, this was a problem that we really started to recognize a few years ago as we were talking to our municipal customers here in Florida. And what that led us to do is to develop a service arm that we christened Bell Fuel and Tank Services. A lot of times we will refer to it as Bell FTS. Now, there are lots of people who have stored fuel, and they know how important it is to do these best practice recommendations. But it's easier and it's more cost effective for them to just let a comprehensive fuel service partner handle it for them. And that's what Bell Fuel and Tank Services does. We cover all of the bases in this respect. We do whatever's needed for the customer, and typically it's done in a more cost-effective manner than it is for them to do it themselves. So, what did we learn today? We start to wrap this up, and basically, we started talking about the EPA tank corrosion study, the largest study in history done to date with 40-plus tanks. They found that more than 80% of tanks had signs of corrosion despite the same normal maintenance practices being done. They found that many of the owners of these tanks didn't even know they had problems. They hadn't seen any signs of it yet. They didn't see any difference between how it affected metal tanks or fiberglass tanks. And so when they considered all of this, the EPA recommended doing a number of different things. They recommended monitoring for and controlling water buildup in those tanks. They recommended filtering the fuel for water and particulate content. They recommended using biocide chemicals and liquid corrosion inhibitor chemicals. And they recommended partnering with tank service companies to make sure that if you have any damaged components in your storage tank, that those are properly repaired. And then we finished up by mentioning that, hey, it can be helpful to partner with another kind of service company, a fuel PM service company like Bell Fuel and Tank Services. That can ensure that your fuel is properly treated, that the best practices are being followed, and most importantly, that you don't have to worry about that. So you essentially take all of that stuff out of your hands so that you can really concentrate on your core business and doing that better. So with that, we start to come to the end of our webinar here. And typically, this is where we will take questions. Now, I have my email up there on the screen, ebjornstedt@bellperformance.net, because typically there are 3 or 4 different kinds of questions that people tend to have. And you may think of some questions that you might have, maybe a little later on. We will definitely be glad to help you with those. Just email those to me at that email address and let me know what you need to know, and I will be glad to help. Now, a couple of questions I had. First of all, somebody, when we were talking about this with somebody, they said, okay, biocides, great. I understand the need for biocides, but their question was, when I put biocides into my fuel and the fuel's combusted, what kind of combustion byproducts do biocides make? And the short answer to that is, they don't produce anything that's different than what the fuel itself will produce. Now, what we mean by that is biocides are considered a fuel additive. They are approved to go in on-road fuel, and any additive, any fuel additive, whether it is a biocide, whether it is a cetane improver, whether it is a cold flow improver, or a liquid corrosion inhibitor, any of those, in order to be approved to be used in on-road fuel, it needs to be composed of the same kind of molecular component that fuel is made up out of. Now, the rationale behind that is that it's not going to cause any problems in the engine because that fuel is made up with. So in answer to this question specifically, a biocide like Biocides, which is a thiocyanate, it's going to be composed of carbon and nitrogen and hydrogen. It'll have a sulfur molecule in it. But by and large, it's the same stuff that you find in petroleum anyway. So the combustion byproducts of a biocide-treated fuel are going to be just about the same as the combustion byproducts of untreated fuel. Another question I had is concerns how often you need to treat with these kind of chemicals. How often do you need to use biocide? How often do you need to use this liquid corrosion inhibitor stuff that the EPA recommends? And that is an excellent question. The short answer is that these kind of chemicals need to be used on a regular basis. Well, what is a regular basis? Well, typically, when we're treating stored fuel through the FTS arm, for example, we will typically recommend that they treat quarterly with at least some of these kinds, especially the biocide. And this is recommended for several reasons. With biocides, you have to have regular ongoing presence of the biocide in the fuel because you need it in there to keep killing the microbes that are going to want to have ingress into that tank. The stored fuel is always having new additions of microbes coming in from the outside, coming in on dust particles from the vented air, coming in the water, stuff like that. You need to have continual biocide presence in order to ensure that these microbes stay killed. And you want to do this because you don't want to leave any resistant microbes in the tank. That falls in the same category as, finishing your course of antibiotics that your GP recommended when you were sick. You don't just stop in the middle of those, right? Because then all you're doing is you just killed the weak bacteria, and the strong ones are still there, and your infection is going to come back in full force. So it's the same kind of concept. But another aspect to this is that you want regular treatment with fuel additives because microbes actually do learn how to metabolize fuel additives. Not so much biocides, because biocides kill them, but a corrosion inhibitor or a cetane improver or a detergent or a dispersant, over time, microbes grow and they adapt and they change and they learn new things, including how to metabolize certain kinds of fuel additives to use as fuel. So that's why it's recommended that you treat regularly with fuel additives to keep their presence in there and keep them providing the benefits that you think they need to. That's the whole reason why you're using them, basically. All right, so we're going to be following up by email in a couple days, and we will have a couple things on there. We will have a link to a recording of this webinar that you can access. We will also have some links to some additional information on some of the things that we talked about. We talked about the Bell FTS program. One of the takeaways here should be that if you have stored fuel at your business and that is something that you've been considering, or if you've heard something that makes you want to learn more, we want to talk to you. We want to basically show you why the Bell Fuel and Tank Services is something worthwhile that you may want to consider. And then also, of course, we mentioned the biocides and the corrosion inhibitors, specifically Biocides and tank treatment SDF. So we're going to follow up with a recording, a link to a recording by email. Couple of things we wanted to close out with. You may have already been to the Bell website, and if you have, you know that it really does have a lot of good information on it, and that's because we set it up that way. We know that people need agnostic information that tells them that is accurate and that is correct, and that has their best interests at heart. And that's really the basis behind the Bell website and all the information we put on there. So we have a lot of good information about all of this stuff at the Bell website, including specifically the blog. The blog, we get probably tens of thousands of visitors to the blog every month, easily. And that's because we try to fill it with good information. So I would encourage you, if you've heard anything on this that you want to know more about, definitely go to the Bell blog. Chances are we've written an article about it that's going to tell you more about the kind of things that you want to know about. And then lastly, again, go to the Bell website or email us, respond to our email if you want more information about Biocides, about the tank treatment SDF, the corrosion inhibitor, or about the kind of services that the Bell Fuel and Tank Services program provides, and we will be happy to get back with you and just start a dialogue with you. So that about concludes our seminar for today. I am, of course, Eric Bjornstad. I'm the Technical Information Director here at Bell. So thanks for joining me today. Thanks for taking time out of your day to listen to us discuss some of these important issues. We will be doing another webinar next quarter. So keep an eye open for that announcement here in another couple of months. And in the meantime, thanks for joining me today, and we'll see you next time. Bye.